Come on. All right. Oops. This is the wrong assignment. This is the one for today, which you guys will be doing. That's not very helpful. I snagged homework 10. I guess I didn't. Okay. All right. So it looks like most of the questions here are just on the first page, which is fine. So we're asked to do 3 things on numbers 1 through 5. So first thing we want to do is determine if the parabola opens up or down. So to do that, I'm going to look at the value for a. Since this is a standard form, I know that the a coefficient here is just -3. So I know this one is going to open down. Since it's standard form, the axis of symmetry is b over 2a. So that's going to be, negative b over 2a. So it's going to be -6 over 2 times -3, which comes out to just be 1. So that's my axis of symmetry. And my vertex, the x-coordinate, is just the same as the axis of symmetry. And my y-coordinate I'm going to get just by plugging that value for x into my function. So 1 squared is 1. -3 times 1 is -3. 6 times 1 is 6. -3 plus 6 is 3. And minus 10 is -7. So my vertex then is just 1, -7. So opens down. Axis of symmetry is x equals 1. And then my vertex is 1, -7. Enzo, you happy there? Okay.
Yeah, thank you.
Yeah, no problem. So the next one, so again, we're going to start by noting that this is in intercept form. So this is my a value here. Since the a is positive, now this one's going to open up. Since it's in intercept form, the axis of symmetry is going to be p plus q over 2. So my value for p is going to be the opposite of 10. And my value for q is going to be the opposite of 8. So I have -10, -8 over 2. So that is x equals -9. And that's also going to be the x-coordinate for my vertex. To find the y-coordinate then, I'm just going to plug -9 in for x. So -9 plus 10 is 1, and -9 plus 8 is -1. So 2 times 1 times -1 is -2. So there's that. Okay. Megan, are you happy there? So far, so good?
Yes, thank you.
Of course. So same idea here. We notice that this one on 5 is an intercept form. So my a value here is really -1, right? Because there's always like a 1 there out front. So we can slide a 1 in between the negative sign and the start of that parenthesis. So that's going to tell me this opens down. And since it's in intercept form, it's p plus q over 2. So my p is the opposite of -3. And my q is the opposite of +4. So that's going to be -1/2. So the x-coordinate for my vertex is that same as the axis of symmetry. And then we get the y-coordinate by plugging that in. So negative 1/2 minus 3 is negative 3.5, and negative 1/2 plus 4 is positive 3.5. Negative 3.5 times positive 3.5 is 12.25, and then we still have that extra negative sign there. So that's negative 12.25. So we have negative 1/2, negative 12.25. And decimals here are fine. If you want to call that negative 0.5, if we're actually going to go and graph things, certainly reasonable to do that. If you had called this like, what would that be? Like 49 over 4, negative 49 over 4, and used a fraction there, that would certainly be appropriate. And then number 2. So number 2, first thing I do is I recognize this is vertex form. So my A here is the negative 3. That tells me that since it's negative, we're opening down. Since it's vertex form, the axis of symmetry is just x equals h. So the h is going to be the opposite sign of that. So it'll be negative 6. And then I remember the shortcut that we can use for vertex form when finding the vertex. So the vertex is always h comma k. So the x-coordinate is that negative 6, and the y-coordinate is that negative 8. You could have also plugged negative 6 back in and evaluated, but you would have gotten negative 8 still in that case. It's not much of a time saver, but, you know, I'll save my time when I can get it. You know what I mean? No sense in doing more work than we really need to. Kalila, are you happy there?
Yeah, the parentheses just kind of threw me off.
Sure.
So, thank you.
Yeah, no problem. No problem. So I think that I've seen a couple more people log in, just as a reminder here when you get to class to type here into the chat. So when I go back and figure out the attendance after we leave, I know who's been here and who hasn't. So if you haven't gotten a chance to do that yet, please do that. Okay. So that was last night's. So the questions you guys were asking were good ones and reasonable ones. So that's excellent. Today we're gonna talk about the last topic in this chapter. So that's going to be modeling. And the idea here is we want to take some info about a quadratic, and by info really we mean points or key features. And turn that into an equation, or really a function. So there's really 3 situations, and depending on which of the 3 situations we have, we'll use one of the 3 forms that we can write a quadratic in. So those 3 situations. So if you have the vertex and one other point, we're going to use vertex form. If you have both x-intercepts and one other point, we're going to use Intercept Form. And the third situation is if you just have any 3 points that we don't know that they're x-intercepts, for example, we're going to use standard form. So these first two are the easiest situations. This one is a little bit more difficult because it involves solving a 3-variable system like we did in the previous chapter. But I'll show you a way to do that on your calculator that'll handle all the solving for us if we can use our calculator effectively. So that we'll do that here a little bit later when we go through the examples. So let's say that we're given a situation where we know the vertex is the point -2, -5, and we're given the other point -4, -13. And we want to write the equation for a quadratic function that passes through these 2 points. Since we're given the vertex, we want to use vertex form. And the reason that is because we know in vertex form, the vertex is h comma k. So I can immediately plug those values in. So all I'm really left to do is figure out what A has to be. Right? If once I know A, I have my quadratic function. So to find A, we're going to use this other point, because what this other point is, it's an X and it's a Y. So I can plug -13 in for Y and -4 into X. And now I can just solve for A. So -4 plus 2 is -2, and -2 squared is +4. So then I'll add 5 to both sides, and then divide by 4, and I have my value for A. So since I have my value for A, I have my value for H and K. I can take those two things, put it together, and say Y equals -2, that's my A, X plus 2 squared minus 5. Right, just like I got when I plugged the vertex H in for H and K. And now I'm done. So the key is remembering which one of the 3 forms that you want to use for the given information, right? So if we're given a vertex and some other point, we want to use vertex form. The vertex gives us the values for H and K. We use that along with plugging the other point in for X and Y to solve for A. And then we can write our vertex form equation. The thing that I see students often forgetting is that our final answer should have X and Y in it, not numbers in those places. So make sure you don't write that with the -13 and the positive and the -4. I'm sorry. still in those spots. Any questions on how we do that one before we move forward? Okay, that's fine. So let's say we're given these 3 points. Now there's a key observation we should make with these 3 points, because these aren't any three old points. Notice that these 2 points, the y-coordinate is 0. That means that they are x-intercepts. So since I have 2 x-intercepts and then some other point, I should be using intercept form. So remember, the equation for intercept form is a times x minus p times x minus q. And the lovely part is that the values for my p and q are just the values for my x-intercepts. So I can plug those in straight away. Notice that I went ahead and wrote the minus and -3 as just +3. Just figured I should mention that before going on. So all that I'm left to do then is I just need to find the value for a. How am I going to do that? Well, I'm going to use this other point that we haven't used yet to find a. This point again is an x and a y. So I can plug those values in for x and y. And use them to solve for a. So 6 plus 3 is 9. 6 minus 5 is 1. 9 times 1 is 9. So I have 8 is equal to 9a. And then if I just divide both sides by 9, I get that a is 8/9. So if I take these two together, I can say y equals 8/9 x plus 3, x minus 5.
Mr. Kulik,
Yes.
so basically in the final answer, you only want the a value, so no x and y values?
Correct. I should have it to write a function. A function needs an input and an output variable, so we need an x and a y in our final answer. All the other parameters, the a, the h, the k, the p, the q, the b or c, those should all have numbers in their place, but the x and y should be still variable.
Okay, thank you.
Okay, yeah, no problem. And let one more final example here. So let's say we have -1, 8, 2, 5, and 3, 16. Notice here that with these 3 points, we don't have any x-intercepts, right? Because none of the y-coordinates are 0. So this is going to be one that we have to do using standard form. So remember our standard form equation is y equals ax squared plus bx plus c. So for me to report an answer, I need to figure out the values for a, the value for b, and the value for c. To do that, or that equation has three variables in it, right? I need to find values for three things, a, b, and c. So what I'm going to do is I'm going to create a system of three equations and solve that system. So the way that I'm going to do that is I have an xy here. So that's going to create my first equation. So I plug 8 in for y and -1 in for x. And that's one equation. I have another xy here. So I'll plug those in. And I have a third xy here. So I'll plug those in. And that's going to form a three-variable system, just like we had in the previous chapter. Now we can simplify this down a little bit before we start trying to solve this. So usually when we write our systems, the equal sign is on the right side instead of the left side. You guys agree with that? And then we have all these things that are being squared that we could simplify. So -1 squared is just 1. And then -1 times b is -1b. And then I'll write 1c is equal to a. And then 2 squared is 4, so I have 4a. 2 times b is 2b. And then plus 1c is equal to 5. And then 3 squared is 9, so I have 9a. 3 times b is just 3b. And I have 1c is equal to 16. So that's how I'm going to write my system. And now I could solve this system by hand. I could use substitution or elimination, just like we did in the previous chapter. But there's another way to do this using our calculator that I'm going to show you guys how to do this. So that you can solve these systems without actually having to do all the algebra. The calculator can do all of the heavy lifting for us here. So I'm going to just talk a little bit of a brief overview on what the calculator is actually doing to solve this system. And then I'll display the calculator and kind of walk through how to do that. So the calculator is going to, what we're going to do is we're going to write this system as a matrix. So a matrix is just like a rectangular array, and where we have like rows of numbers and columns of numbers. So like rows are up and down. Columns are up and down. Rows are left and right. So this particular system is going to have one column for the a variables. And I'm just going to type in their write in their coefficients. And one column for the b variables. And then one column for the c variables. And one column for the answers. So that's what we're going to type into our calculator, is a matrix that looks like this. And then we're going to use a command called rref, and it's going to output something that looks like and somehow that matrix that the calculator outputs is going to tell us the values for A, B, and C. So let me explain to you kind of how to read that output so you can understand what that is telling us. So notice how the row of the original matrix that we wrote is basically the same as the first equation, just we've removed the addition and subtraction symbols, the variables, and the equal sign, right? But the numbers are still the same numbers in that equation. Do you guys notice that? So if we do the same thing here, this would imply 1a plus 0b plus 0c is equal to 3, which just implies that a is equal to 3. If we do the same thing for this row, that's 0a plus 1b plus 0c is equal to negative 4, or just that b is equal to negative 4. And if we look at the last row, it says 0a plus 0b plus 0c is equal to 1, or just c is equal to 1. So I could write 3x squared minus 4x plus 1, and that's my final answer, which is quite a bit easier than having to do the substitution or eliminations that we were doing last chapter. So let's show you guys now how to type this into your calculator. So we'll be typing something like this into our calculator, and then using this command on it, and our calculator output this as its answer, which we would interpret as a equals 3, b equals negative 4, and c equals 1. Notice the last column is all we really care about there, right? It tells us in order the answers for a, b, and then c. So if you have your graphing calculator with you and you'd like to follow along, you're welcome to do that. If you want to just sit and watch and try it again later on your own with the video, where you can pause and whatever while you look at stuff on your calculator, that's totally fine too. I'm just going to pause here for just a couple of seconds in case anybody needs a minute to grab their calculator, if it's not handy with you on your desk or table or bed or wherever you're sitting to do the lesson today. Okay. So what we're going to be working on is entering this matrix into our calculator. So to do that, we're going to be using the matrix menu, which you can locate here. See the blue word above the x to the negative 1 button in blue is the word matrix. So if I press the second button and then that x to the negative 1 button, that opens up the matrix menu. And the matrix menu has 3 tabs. It has the Names tab, the Math tab, and the Edit tab. If I'm going to type a matrix into my calculator, I need to be using the Edit tab. So I'm going to go ahead and use my left and right arrows to move over so that I'm on the Edit tab. Now, I have all these numbers here because I have stuff entered into the matrices in my calculator already. You guys, this is all probably blank, which is fine. No big deal. And in fact, I'm going to use matrix A that I already have here. I'm just going to type over whatever I had in there before and just replace what I had with the matrix that we're going to write right now. So I'm going to just select matrix A. And this number here is just telling us the dimension of the matrix. So my matrix has 3 rows and then 4 columns. So the dimension that I need is 3 by 4, so I'll type 3 and press enter, and then 4 and press enter. And now if you look at my screen, it looks like there's only 3 columns, but if you see these little dashes here at the end, it's telling me that there's more off the screen that I just can't see right now. So that's where my 4th column is. It's just off the screen. I can't see it. So I'm just going to type in exactly what this looks like. So again, I got these numbers by just taking the coefficients from my system, right? There's nothing special about how I got the numbers that I'm going to type in. So the first equation was 1, -1, 1, and 8. So those are the numbers in the first row of my matrix. So I'm just going to type the number 1 and then press enter to move to the next spot, -1 and then press enter, and so on and so forth. Let's go ahead and type in that whole matrix. And we'll do another example of this here when we're done, where I just give you the 3 points and let you guys try it on your own for a few minutes so that you can practice doing this. So don't feel like you're going to get one example of doing this and then be done. This is, I think, quite a bit more complicated than the other 2. So I want to make sure that we give you guys a second opportunity to kind of see this and practice this. Is anybody still typing into their calculator? Okay, very good. So what we'll do now is we'll exit back to the main screen of our calculator by pressing the second button and the mode button that's right next to it. Now what we need to do is go into our matrix menu and retrieve the command rref. So we do that by going back to the matrix menu by pressing second and the -1 button. And this time we're going to go over to the Math tab. And then we're going to scroll down until we see the command rref. Make sure you use the command rref and not ref. So there should be 2 R's. So once you've located that command in your matrix menu, go ahead and press enter and it'll paste that onto the main screen of your calculator. And now I'm going to go back to my matrix menu and retrieve that matrix A that we just wrote, because that's what I want to do the rref on. So I'm going to press second and then the -1 button. And then from the names tab, I'm going to select the matrix A that we just wrote by pressing enter. And then I'll just close my parenthesis at the end and press enter. And there's my output from the calculator that we interpret as A = 3, B = -4, and C = 1. I'm going to give you guys a new set of 3 points and 5 or 10 minutes and let you guys try to do this process on your own, and then we'll walk through it together. So you get some practice setting up that system and then writing that system as a matrix and then using your calculator to do these matrix this matrix operation to get the answer to that system. Okay? And I know that at first glance it feels like this is probably not any easier than solving the system by hand, but once you get good at this, it is quite quick and a nice time saver. So I'll give you guys another example. So here's a new set of 3 points. So we have -1, -3. 2, 5, and then 4, -3. Okay, so take here, let's say we'll come back together at say like 8:35, and kind of run through what to do here. As I periodically, I'll write a little work in so you guys can see as you're doing things, like you can some checkpoints that are kind of along the way, so you can see if, oh shoot, I goofed that up or whatever, as you guys are working. But I'll give you a few minutes to get a head start before I start writing stuff in, and then we'll talk through it all at the end. Okay? Okay, so let's kind of talk through what we did, and then I'll demonstrate again how to do this with our calculator. Okay, so each of these points represents an x and a y. So I took turns with each point plugging the x and y into my standard form equation. So the negative 13 went in for y, and the negative 1 went in for x to give me my first equation. And then 5 went in for y, and 2 went in for x to give me my second equation. And then negative 3 went in for y, and 4 went in for x to give me my third equation. I then simplified down, so I did all these squares, and I wrote the equals on the right to give me this system, which I then interpreted as a matrix. So the numbers in my matrix were 1, negative 1, 1, negative 13, and 4, 2, 1, 5, 16, 4, 1, negative 3. That's how I got the numbers here. To enter these into my calculator now, I press second, and then the x and the negative 1 button to open the matrix menu. I went over to the Edit tab. I'm just going to put these numbers back into matrix A, the same matrix I used before. So the dimension of my matrix remains the same. I still have 3 rows and 4 columns, so I just pressed enter twice. And now I'm going to just type in my new numbers. So 1, negative 1, 1, negative 13. And notice I can just type over what I had there before. 4, 2, 1, 5, and then 16, 4, 1, negative 3. Once I've done that, I can exit out by pressing second and the mode button. Now on the main screen, I want to get Rref of Matrix A. To get the Rref, I go back to the matrix menu, so I press second and the x and the negative 1 button. This time I move over to the Math tab, and I scroll down almost to the bottom until I find the command rref. I'll select that by pressing Enter, and then I'll go back to my matrix menu, second, x to the -1. From the Names tab, I'll select Matrix A, the one that I just made, close my parenthesis, and press Enter, and that's my output. Remember, the last column of my output is going to give me my answer for A, and then B, and then C, which I just plugged into my standard form equation to get my answer. Any questions on this one? Very good. So this is all I needed to do today for you guys. So I'm going to dismiss you in just a moment. But before I do that, I want to point out that I have added a homework 11 that's practicing doing these skills to the content library on OneNote. So there's just 6 problems where I ask you to do this. Also, today, I've made a homework quiz on PowerSchool, but it's formatted a little bit differently than what we've done before. If this wants to open and load for me. Okay, so if I go to our class page, and I look at the bulletin board here for first hour, you're going to see a factoring homework quiz tab, or a content block. So this is a fill-in-the-blank quiz. So I'm going to give you a quadratic and ask for the factored form. You'll type your answer in the blank. To get full credit, you need to make sure you format your answer in the following ways. So you can have no spaces in your answer. So for example, an answer like x minus 2, x plus 3 is a good answer, but x minus 2 with a space and then x plus 3 is bad. That'll be counted as wrong. Unfortunately, there's too many things. I can only have so many correct answers possible, so I have to be a little bit picky. Additionally, I need you to make sure you're using subtraction symbols and not like plus some negative. So again, x minus 2x plus 3, that's good, but don't write x plus a negative 2. You need to make sure you're writing that as x minus 2. Again, I can only have so many correct answers here on the quiz, so I didn't want to fill it up. It doesn't matter the order of your parentheses, so whether you did x plus 2 times x plus 3 or x plus 3 times x plus 2, that doesn't matter. The capitalization on your letters doesn't matter. If you encounter something that's not factorable, just type NF for not factorable. It doesn't have to be capitalized. And you're going to get 2 chances for each problem, although if it takes you a second try, you're only going to get half credit on that attempt. So there's 10 questions, and I think I gave 15 minutes to handle that. So it starts at, or this ends at 9:05. So we should dismiss you here from class so you guys can take care of that here today. Any questions about that before you go? Okay. Well, you're all dismissed. Don't forget to type bye in the chat before you log out. And I'll have a good weekend and a happy Thanksgiving and all that jazz.
Thank you, Mr. Kulik. Have a good Thanksgiving.
Yeah, you too.